Hello, ladies and gentlemen. My name's Simon Timpley from the International Food Safety and Quality Network. Welcome to edition 88 of the Food Safety Fridays webinar program. It's good to be back after the season and the season break. We've got 26 webinars in 2018, and this is the first one, so we're delighted to be back. Today's subject is best practices for effectively implementing an ATP sanitation verification system. And we have two co-presenters today. We have Jim Topper, Senior Market Development Manager from Neogen Corporation, and Kathleen Wyborn, Director of Food and Beverage USA Canada DNVGL Business Assurance. And DNVGL are a new sponsor of the Food Safety Fridays webinar program. These webinars you get free of charge. Obviously, you get a free certificate of attendance, some education, but they are sponsored by DNVGL, as mentioned, Trace Analytics, Safe Food 360, Metal at Toledo, and AIB International. So, okay, at this point, I'd like to introduce you to Jim and Kathleen, if you can switch your webcams on. Hi, Kathleen. How are you doing? Can you switch your microphone on as well?
Sure can. Good morning, good afternoon.
Okay, Kathleen, can you let the audience know where you're calling in from today?
I am calling in from Chicago in a warm 16 degrees Fahrenheit.
Yeah, it looks nice and sunny through your window there.
Yes.
And Jim, where are you today?
I'm in also sunny Lansing, Michigan, where it is about the same temperature, and we're getting a tremendous snowstorm this morning.
Right, okay. And I'm in rainy Manchester in the UK, England, and I'm full of a cold, but never mind, the show must go on. Okay, do you want to get your slides ready? And while I let the audience know about next week, you might see in the sidebar, behavioral-based food safety. Next week, it's not a Food Safety Fridays, it's actually a training course. So it's $97 actually, but it's a 3-hour training course with David Rosenblatt, who's absolutely fantastic. He's going to be talking about the MAC model early on in the year, a way to kickstart your food safety culture improvement and give you some real good tips and methodology for that. So hopefully you can join us for that. Are you able to get your slides up, guys? Yep, there we are. Okay, so I'll be back for the polls later, but for now, I'll hand you over to Kathleen first and then Jim. Okay, guys?
Okay. First of all, I'm going to talk a little bit about DNVGL and how certification fits in with the subject of understanding the food safety technologies around testing and the safety challenges that we have in the industry. Just a real short about DNVGL. We're one of the top 3 certification bodies in the world, and we have issued more than 80,000 certificates to over 10,000 companies. As far as what we do, we deliver certification and verification, assessment services, supply chain assessments, and training in all the different standards and food safety topics. Located globally around the world, a large global footprint. We work with both the large multinationals and also the smaller companies, so of any size. As far as certification services and what certification is, a certification audit is intended to evaluate the level of compliance with a standard and scheme. So the most popular being, of course, the GFSI benchmark schemes that are offered to the food industry, and some of the more popular schemes are the FSC 22000, IFS, BRC, and SQF, and these are benchmarked to help prevent food contamination in the food industry. More specific around the topic around prevention for food contamination, within the standards there are some basic elements that all good food safety plans need to have to help with the prevention of microbiological contamination. And the first, starting off with the most important to me, is always the management commitment and having the resources, the funding to have a good food safety plan. Second being, of course, the training, the awareness of the personnel that work directly, not only in food safety, quality, microbiology, but on the line, the operators and their awareness to microbial pathogens, contaminations, and understanding the risk and what they do day in and day out and how that can affect the infrastructure and how the buildings are built, the availability for the resources to clean properly, to have good cleaning in place procedures, testing, validation, and the control measures being one of the most important around cleaning and sanitizing. And just here from the ISO TS 22002, cleaning and sanitizing programs shall be established to ensure that the food processing equipment and environment are maintained in a hygienic condition. Programs shall be monitored for continuing suitability and effectiveness. Implementing and cleaning and sanitation, the plans must have detailed procedures around the cleaning activities, the frequencies, who's responsible, what kind of test methods are being used, and what cleaning and tools and chemicals are being used to clean the equipment. And most important to me, and that we see in the auditors that work for DNVGL, is something that I think has always been a myth in the industry, and it's not that complicated. And it's the difference between verification and validation, and who is responsible for this, the frequency methods, and how is this maintained, and what are the methods for cleaning and sanitizing. Is it visual inspection? Is it ATP swabbing, cleaning in place liquid testing, and just to mention some of it. For us and for what the auditors see, really finding out and digging into the personnel's ability to understand what they're doing and the requirements. There's a lot of good testing that's going out in the industry, but really understanding the principal methods behind these and why they are doing this, and sorting out the results, the detection limits, if they get false positives, what to do. Are they sampling correct? Do they have the correct sampling size? So there's a lot of science that goes into a good test plan. Achieving certification, meeting the requirements of the GFSI standards. The first things to do, of course, is to understand what the standards are and determining the scope of the certification for which you want to apply. Checking both your customer requirements and also the different GFSI schemes to understand what they have in them, their contents around all the different food safety requirements, what's required around implementation and requirements, selecting a certification body, and with that, for specific to DNVGL, most certification bodies are able to provide pre-assessments, trainings, and of course the certification to one of the GFSI standards. And with that, I'm going to turn it over to Jim, who's going to take us into the detail of testing methodologies, verification, validation, and I'm happy to turn it over now to a great presentation around food safety. Thank you, Jim.
Well, thank you, Kathleen. I want to start by saying that the contents of this presentation have been excerpted from a handbook that we put together, I think about 2 years ago now. And there were a number of people that were involved with that effort in the food safety and sanitation area. But two, I want to make sure that we mention Dr. Robert Donofrio, who at that time was with another company, but is now our Director of Food Safety R&D here at Neogen. And then Becky Michaels, who is the Corporate Sanitarian for PepsiCo, also was a key participant in this effort. And I believe there is on the sidebar an opportunity to download this document, this handbook. Hopefully you should be seeing that now. If not, we'll talk about with questions maybe later, and it's also available off of our website. But again, you should have that on your sidebar, the opportunity to download, and we'll keep that up there for a little while. All right, so the handbook really was based on a couple of key assumptions, and those assumptions are that a sanitation verification program is at the core of any food safety initiative. If you don't have a clean and sanitary environment, then you don't have food safety. And the other thing that we have to acknowledge is that ATP systems, adenosine triphosphate sanitation verification systems, have really become the de facto standard that most people are now using to measure the effectiveness of cleaning efforts in their facilities. All right, and those systems, the ATP systems, actually measure a molecule that's produced in every living cell, adenosine triphosphate. And as such, it indicates the level of organic material on a surface. But if you want to be really accurate, really specific, more accurately, it measures the amount of cellular-based material that's left on the surface. And that organic material can be a reservoir for things like microbes, including spoilage or pathogenic organisms, allergens. And then the systems really have become a gauge for the ability for our SSOP to remove soil. That's the real key to the system. And although they've had widespread use in food production industry for more than 25 years, I still see a lot of programs that are relatively simple, not based on logic, not really standardized, and what I would call not fully optimized. And what I mean by that is they don't deliver everything they could in terms of value to the manager. So this brings us to our first of two poll questions. I'd like to get a sense from the audience just where you think your ATP sanitation verification program is at your facility. So we should be seeing a poll appearing on the sidebar. Simon, I think, is going to come in and tell us how to work this. But basically, the question is, how would you characterize your program? And the answers are, we don't have one. Second choice is it's relatively simple in that our team goes out, basically takes a test, we decide pass, fail, and we move on with production. But really no attempt to collect data. The third level is that we do collect data, and that results are occasionally reviewed for a simple trend analysis and things like that by location. And then the fourth level is something where it's much more data intensive, where we make it an active part of our program, where we go out, we collect the data in addition to the test results, and we review them regularly, and we've actually used the data to help us become more effective with our cleaning.
Yes, Jim, can you see the poll in the sidebar?
I cannot, but I'm looking at the presentation.
Okay, well, we don't have one, is 20%. Simple pass-fail with no data collected is 14%. Location data is collected for simple trends and analysis, 34%. And data is collected and reviewed regularly and has helped our location become more effective with our cleaning is 32%. So, yeah, it's skewed towards the more intensive, actually. But although 19% do not have any.
Yeah, that's a pretty good representation. It's good to hear that levels 3 and 4 are the more popular choices. So, all right, we'll move on. Let's talk about what we mean by validation with an ATP sanitation verification system. So, when we talk about validation, what we're really referring to is the process that your facility is going to undertake to ensure the effectiveness of a particular operation. And specifically, this is about cleaning. And we start by defining what the objective of the cleaning process is, and it is to remove particulates, residues, microbes, etc., to a safe or satisfactory level. It must be based on logical assumptions and inferences, and it must be based on measurable results that we can use going forward, that can be translated to meaningful standards that we'll apply in our next level, which is verification. It's typically performed once until the expected outcome is achieved, and then repeated on a scheduled basis or when our key assumptions change. And we'll go through what constitutes a change a little later in the presentation. So based on that definition, I've got the second of my poll questions. Has your facility conducted a formal validation study to establish effective baselines for your ATP sanitation verification program? And the answer is yes or no. We use the values that came with the system or that our vendor recommended. And then thirdly, I don't know.
Okay, Jim, I've loaded the poll in the sidebar, and I can tell you that yes, 25%, no is 50, just over 50%, 50%, and I don't know is 20. So it's actually yes 30, no 50, and I don't know 20.
All right, well, that's a pretty good representation there as well, and I think probably representative of what's happening in the industry. All right, so when we talk about verification versus validation, what we're referring to there is the routine monitoring of your process to determine adherence to our validated standards. Verification is performed after each cleaning event, and the results are compared to our performance levels that we established during our validation process. And then results outside of that standard indicate some kind of a failure in our SSOP. And very often our verification routine is a part of our SSOP. The real challenge, though, when it comes time to clean to this validated standard is establishing objectives and standards that can be measured in a meaningful way. We start by acknowledging that most food safety contaminants are either going to be microbial, chemical, or allergenic. And once again, the optimal cleaning occurs when that stuff is removed or rendered inert. Very typically, this is a two-step process where we clean for the removal of the soil, and then we sanitize for the microbial kill step. And then the ATP testing typically follows step one, unless the sanitation step also removes soil. So if you've got a sanitation step that will result in the removal of more soil, then it might make sense to do your testing at that point. But if it does not, if it's just a spray foam where it just sits there on the surface, you would want to do your ATP testing obviously before that, so that if the results fail, we haven't wasted our sanitizer. All right, so when we talk about validation, there's a few steps we want to go through. First step is we need to identify the different test sites we're going to use to monitor that our sanitation efforts are in fact valid. And that step is really the process we go through to identify what's called a test plan. And as we go about our facility and we look at where we're going to do our testing, what we're looking for there are unique surfaces, unique cleaning, or where unique cleaning occurs. Harborage sites should be a particular focus, difficult to clean sites also. And we also want to make sure we monitor non-food contact surfaces, because those could be instrumental in cross-contamination to our food contact surfaces. And last thing we want to keep in mind when we identify something that we're calling a representative test site is what that means if a test fails for that site. So in other words, if we identify a single 4-inch by 4-inch surface, let's say on a conveyor belt surface, if that surface fails, the implication is that we re-clean that entire belt. If we sample something that is a smaller subset of it, then of course it implies that we clean that smaller subset. So you got to keep that in mind as you define your representative test sites. And then when we do our validation of our cleaning, we want to try and get to a point where every one of our test sites fails at, or rather passes at least 3 times. All right, and then when we conduct our monitoring program, it's really important that we establish a standard sample. Most often on flat surfaces, that is a 4-inch by 4-inch surface. But we got to keep in mind, again, if you go out today and you do a simple 2-inch by 2-inch surface sample, and you go tomorrow and you do a foot by foot, I mean, you're taking a different sample. So it's important that we standardize on the samples that we take in our equipment. It's important to avoid standing liquid. It can dilute the sample. And where we can't do a 4-inch by 4-inch surface, try to standardize on something that is approximately 16 square inches if that's possible. And if we're sampling liquid, we need to make sure that we're using the appropriate sampling devices. Most of these ATP sanitation verification systems have a specific device for sampling liquid. Make sure you use that, because these surface samplers are typically saturated with some sort of a extraction solution. Important also to keep in mind that ATP, of course, is on our skin and in our saliva and things like that. We want to make sure that as we go about our sampling process, we are not contributing to the contamination as we go. And the other thing to keep in mind is that if we do encounter a wet surface and we take a towel and we clean that surface, well, we've changed the cleaning that was done. The test at that site would no longer be representative, so we try to avoid that as much as possible. All right, and then these systems display what's called a relative light unit as a value. And that's really a function of the amount of light that's being generated by a chemiluminescent reaction that's occurring within each one of the swabs or the sampling devices. So I think everybody knows that the formula basically is that there are two chemicals, luciferin and luciferase, that are in the sampling devices, and when those substances come into contact with ATP, light is generated. Again, that's called chemiluminescence. And basically, higher relative light unit scores indicate more ATP or organic residue on our surface. Very typically, people establish a pass threshold, and let's say that's between 0 and 149 as an example. And let's say our marginal threshold would be 150 to 299, and our fail would be above 300. So those are somewhat typical threshold settings, but what I would tell you is that you want to set your own, and I'll go through a little bit about that in just a minute. But that can vary significantly due to a number of different things, including the food that you're producing, the individual surface type, and then real-world time constraints. I mean, there are a lot of situations where if we had 4 hours to clean, we could get our numbers down to 0, but we don't have that. In the real world, we've got a half hour or 45 minutes or whatever the number is to make that product changeover. So we got to deal with real-world situations like that. But basically what that pass value should tell us is that our SSOP was executed successfully. I mean, that's really what we're trying to equate this to. All right, so I'll go through a couple examples of how to establish effective thresholds for your ATP sanitation verification system. So what we recommend is, again, you may start with the defaults that come with the system. You know, we do that here at Neogen. We tell people, all right, this is where you started. But it's important to establish what is the norm in your facility. And the way you do that is you go about taking a series of measurements, and it typically takes several weeks, to achieve some kind of representative sampling at each test site. So we want to see at least 6 to 10 readings. And if at the end of that process you're not seeing some kind of pattern, you want to keep going. But to kind of give you a very simplistic example of this process, I mean, if you look at the results for what is portrayed here as conveyor belt number 1. And on day 1, we got a 275. On day 2, we got a 110. Day 3, 109, etc. So you see 10 readings there, and you could deduce from these readings that there's evidence to support a range of 0 to 120 for your pass, because 7 of our 10 readings are within that range. Days 1, 4, and 7, something happens, some sort of a failure in our SSOP. And contrast that to something like this. So here's the results for conveyor chute number 2. And you see day 1, we had a good result, 75. Day 2, 446. Day 3, 109, etc. So when you look at this data, there is support for a 0 to 125 pass range. Since 5 of our 10 readings are there, it's clear we can get there. But in my perspective, there's a little too much variability here to understand what's actually happening. Data like this would suggest that we would want to investigate a little bit further, and maybe even that our process isn't fully in control. And so the last point here at the bottom is that once we have established our thresholds, in other words, we know what the situation is for our current SSOP, that gives us a baseline to judge new process improvements. We can try some new things and gauge those new things against our established standard. All right, so once the validation has been completed, we're going to move to the verification. And really that implies now from a sampling method where we're sampling everything every time to something that's more representative that is done again on a routine basis. And the goal of our sampling should be to establish a routine that provides representative sampling of each cleaning event. So you got to step back from this. You say, all right, when we shut down, we break down for this product after we've done producing it. What do I need to test? What locations do I need to test to give me confidence that the cleaning was completed successfully? So there's no real set formula for that. But there are a couple of general things. I mean, more variability in your test results implies the need for more test sites, where more consistency implies the need to test a little less frequency. So as an example, if we have 30 test sites in our test plan, we might settle on 5 or 6 sites per cleaning event as our representative sampling. But the quantity is really a function of a number of different things. One is your comfort level, your confidence level. Again, are we seeing a lot of variability? We have consistency. We feel comfortable with what we're doing. Product risk is important here. Some people like to see every test site sampled, let's say, at least once a month. And they want to make sure that that's a part of their program. And then the other thing is change. I would include actually a fifth component in there that I didn't put there, but certainly, you know, cost. What we're doing obviously is what we're doing, obviously there's some cost involved. So we need to obviously function within our budget. All right, and then when it comes time to actually interpret our results, you know, what does this pass-fail data actually translate to? There's a couple different perspectives that people take. One is a post-op perspective. So in other words, if you produce product, let's say from 6 o'clock in the morning until 6 o'clock in the evening, and then you break down for a couple hours, or rather you break down, you do your testing. At that point, really what your testing is telling you is that your cleaning was successful from the previous production event. If, on the other hand, you come in the morning, let's say you start back up production, you do your testing at 6:30, 7 o'clock in the morning, then the implication is that the surfaces on which you are about to produce product are safe for production. So a couple of different ways we can look at this test data. And sometimes they're the same thing, but really it's a function of a couple of things. One is the time between your testing and production. So, you know, if your testing occurs at 8 o'clock at night and your production doesn't start back up till 8 o'clock in the morning, maybe that's too much time to make that inference that the surfaces are safe for production. The other thing that will factor in here is what's happening around that equipment while it's down. I had a call some time ago from a woman who was using our system for a number of years, and she was in a pre-op kind of approach. And she mentioned that all of a sudden, I think it was a week before, her numbers were going up, and she couldn't figure out why. And she said they produce product between 8 o'clock in the morning, 6 o'clock at night, test it 6 o'clock the next morning. And again, up until a week ago, everything was fine, but now they're seeing high numbers. And I asked her a number of questions, and we finally figured out that what had happened, and a light bulb went on in her head, is that the week before they had just started production on a line overnight right next to this line. And so again, it's now suggesting maybe a little different approach. All right, so we talked about the validation step. And it is something that we want to review on a regular basis, every year or two, whatever, again, people are comfortable with. But there are things that can occur that suggest that we need to take another look at our validations. So basically, what that implies is that whatever assumptions you have made with your validation, something's changed. It might be some equipment changes. We may have had an environmental contamination event, a fire or flood or something, the sprinklers went off, whatever. Changing our cleaning chemical supplier, our process, our provider, etc. And then potentially any kind of changes in product might signal the need for a revalidation. All right, and then the other thing we want to make sure that we fully understand, appreciate, is the fact that the optimal SSOP provides both an effective and a consistent cleaning efficacy. It's good that we can get rid of this soil effectively, but if we can't do it every time, we're really not where we need to be. So inconsistent results can occur if we're producing different products. You know, maybe we've got something that's stickier here that we're producing. And maybe that implies a need to adjust our SSOP for that particular product. It could also imply inconsistent cleaning behaviors. So maybe we've got different staff, they have different objectives, might imply the need for retraining, or different methods that yield a more consistent result. And so, like I say, once we've got that SSOP both effective and consistent, now we can look at process improvements. We can try new products, procedures, and gauge them relative to our thresholds that we've established. And the other thing that we can do with this data is that when we find a new process improvement that results in, let's say, a 20% reduction in our ATP averages, we can take that data to our management and say, look, I need to make this change, and this is why. Or I need 1 or 2 more people, and this is why, because I can improve my numbers by this percentage. So again, it gives us some data with which to make very important decisions. So when we talk about interpreting the ATP test results, it's important we understand what we mean when we say that, well, that's a good result. It's important to keep in mind that every facility should have their own version of what's good, based on their objective process and validation to set their own standards. Again, don't rely on whatever numbers you've been given by somebody else, because every situation can be unique, and it's important to establish your own normals. So when someone tells you, all right, here's where you should set your thresholds, think of that as sort of an industry standard. There is such a thing. Again, we use them here at Neogen. This is where we tell people where you want to start. You know, so that would be a typical for a stainless steel surface, you know, but again, it's important to determine what your own are. And then here, the point I want to make is that test results are most valid relative to themselves. So in other words, when you test your piece of equipment after your cleaning once, the second time you test it, it's much less improvement. We implement it, we document it, and then we adjust to the new normal, because now what we had before has changed. We can do better, and we adjust our thresholds accordingly. And this should be a process that we're constantly looking to repeat. We're always looking for ways to get better, hopefully. All right, so these systems can be used for sampling water, but this does take a slightly different approach and a different perspective, I think. It can be a valuable tool, but the key is to establish a typical baseline. In other words, what would we normally expect from this water under normal conditions? And what we're looking for, what we're monitoring there is changes. We're looking for spikes that might signal, for instance, microbial growth in our water. And at that point, maybe we know to apply an antibiotic to knock back the growth. Or it might signal a failure of a process. Maybe we got a leak somewhere. Or it might signal the carrying load limit of our water has reached capacity. But it's important to always keep in mind that low ATP scores in water doesn't mean the water is clean or safe to drink. I think the important thing here, again, is that if you're going to monitor your water, do so with the expectation that if you're not seeing numbers, in other words, if you're always getting 0, that this might not be the best way to monitor your water, because a lot of stuff could be happening below that 0 that you're not seeing. Whereas if we monitor our water, we see 100 as a baseline. Now at least we know, we can see variability and understand that something is happening. If we're not seeing anything, then we don't know really. It's not within our range. All right, and then I want to make the point that ATP sanitation verification is a terrific environmental testing tool, but it's not obviously the only one we should be doing. And Neogen, we kind of look at it as a three-legged stool where you've got ATP for your general sanitation efficacy, but you remember that it doesn't always identify every potential danger. And that's certainly true with allergens, because an allergen is a protein. It's not ATP, it's something different. So the levels on a surface don't necessarily correlate. So allergens should be something that we're testing with a specific allergen test. It's just too important of an issue. And the other thing is microbial monitoring, both from a general micro and specific pathogen perspective. We ought to be having a monitoring program there. There too, the results may not correlate with plate counts because again, it's a different thing we're measuring. And also the thing to keep in mind is that microbial, obviously, presence can be impacted at least as much by our sanitation step. So, you know, it's a different thing to measure. All right, and then since we're talking about environmental monitoring, I want to make sure that I make you aware that Neogen just recently introduced the Listeria right now system. And this thing is very, very unique in that it's a complete system for taking environmental Listeria tests. It's got molecular level accuracy, requires no enrichment, and features a total time result of under 1 hour. We're seeing a lot of interest in this now. And you can see that if you'd like more information, you go to our website and download or read the information on the webpage. All right, the last thing I'll tell you about ATP testing is, you know, you do occasionally get anecdotal comments about interference from cleaning chemicals. It shouldn't be a problem because all of the sampling devices have a buffer, typically, that is there to counteract the pH effect of a sanitizer. But I can tell you that, you know, in high concentration, that can be an issue. But this is something that we should discover in our validation process. We should see it as we go through that process. And the last thing is that the chemiluminescent reaction that's occurring within those sampling devices is enzyme-based, and that implies a dependence on temperature. So it's important that we remember that temperature would and could play a role in the number that appears on our instrument. But the most important thing is that it's consistent. So if, for instance, today I go into a refrigerated setting and I test a site that's at maybe 28 degrees, and then tomorrow I go back to that same site and it's still 28 degrees, that's okay. We would expect maybe a little bit lower of a number because of the temperature, but again, as long as it's relative to itself, it's a valid comparison. Where we'd run into an issue is if today it's 28 degrees and then next week it's 72 degrees. We would expect that the difference in temperature would affect the number that appears on the instrument. All right, so that is my presentation, and I think Simon will address questions.
Yeah, if you can stop the presentation now and switch your webcams and mics on, Kathleen as well. There's been a lot of comments. I'm going to try and if you did ask a question earlier, maybe you could retype it in because I might we might not see it because it's too far down. But I think there's one from Amit. How effective is ATP testing in surfaces with biofilms? Is it possible to get a false pass result for such an insanitary surface?
Yeah, and I would say, yeah, it is possible. Depending on how much friction you apply to a surface, you may not break open that biofilm, may not uncover it, etc. Our AccuPoint sampler actually has a flat sponge that is designed to be more effective at uncovering biofilms, but I would suggest that this is definitely something that you want to take into consideration. It can be an issue.
Okay, Sarah, should you swab before or after sanitization?
Yeah, as I mentioned earlier, most people take the approach of sampling with ATP after cleaning before sanitizing. And again, the idea there is if you wait till after your sanitizer, you could potentially have wasted sanitizer. If you get a fail, you need to re-clean. But where you might want to consider after sanitization is if the sanitation step, like I said, removes soil. That's really what it's all about, is the removal of soil. So if your sanitation step actually removes soil, then you would, in theory, get a lower number with your ATP system, and that would still be indicative, representative of the surface's ability now to be used for production.
Okay, and Naz, you see that one? It was mentioned that do not swab standing water. How about sanitizer? If the surface is wet with sanitizer, can I swab it?
Yeah, so my response would be I'd try it and see. My initial thought would be no. If you see standing water, if you see liquid that's clearly sanitizer, I would try to avoid sampling that area. But again, I think if you try it and you see odd results, then clearly the sanitizer and or the presence of the liquid is have an effect on the test result.
Okay, Dominic. I use ATP testing in saltwater wet operations harvesting shellfish. Is this type of test appropriate for non-RTE live in shell clams and oysters?
Yeah, so what I'll tell you there, I don't know. I don't have a lot of experience in that application. The theory is if there's ATP on a surface, we should detect it. Now, I have heard anecdotally that salt can impact the chemolysis reaction. I would say, again, try it and see if this is a good application and see if you're getting results that make sense. Unfortunately, again, I don't have a lot of experience with salt water, so I don't have anything more to add for that.
Okay. Lillian, when we conduct ATP validation studies, should we correlate ATP readings to plate counts?
Yeah, very common question. And what I'll tell you is that you can't help but do things like this because you'd like to see a correlation, but when you do this, you have to remember that there won't necessarily be a correlation because we're measuring two different things. ATP obviously is measuring all cellular-based organic material that's left on the surface, where plate counts are about bacteria, and there's going to be things on the surface other than bacteria. So you could get a very high reading, very low plate count, but it's still telling you that they're both correct. There was a lot of ATP. There just wasn't a lot of ABC or whatever it is that we're using for our plate counts. So what I think people do this for is hoping for a correlation. Sometimes you'll find it, sometimes you won't. But again, don't depend on it. I guess that's the point I would say. Is that if you get one, then that's wonderful. I'd say it's relatively rare that it's really good. But again, don't think that you don't still need to be doing both of these testing, because they are two different things, and the systems are measuring two different things as well.
Okay, thank you. Neil, should refrigerated swabs be allowed to, should they come to room temperature before using?
Yeah, the answer is yes. Again, I mentioned the temperature dependence of the enzymatic reaction. So yes, every one of the swabs and samplers that are in use today should be equilibrated to room temperature before use. Usually that doesn't take very long. With our system, it's only, I think, 10 or 15 minutes.
Okay, next one. Ali, will improper rinsing of detergent and sanitizer affect the ATP results? I think you've sort of answered that before, haven't you? I think.
Yeah, well, it will affect the results. It's still an accurate representation of what's on that surface. So what you would potentially gain from that information is that you're not rinsing consistently. So maybe that's some good information.
Okay. have we got there from Judy? Yeah, can you see that one, Jim? We're going to start using ATP testing for allergens. Will ATP be able to measure the presence of any or all allergens?
Yeah, and the answer, Judy, is no. We do not recommend that. Again, they're two different things. ATP is an adenosine triphosphate chemical in every living cell. Allergens are proteins. And very often there will be a correlation in our cleaning's ability to remove both, but that's not always the case. So if you're going to make this assumption, make sure you validate it. Make sure that you start by validating and correlating your ATP testing with an allergen-specific test. And yes, okay, now we can say that our cleaning does remove both, and we can use one or the other as an indicator. But like I say, you really got to validate this assumption. The default answer is no.
Okay. Nida, can we use ATP swab to validate live cells?
Yeah, so I guess I would wonder about that application. So any cell, alive or recently dead, still has ATP in it. In order to get the ATP out, you really have to kind of break open the cell. I would need to know more about this application. Again, ATP test system is not going to tell you the cell is alive or dead. If that's your application, no. It really would not distinguish between the two.
Okay. Venki, how does Neogen compare with ATP units such as Hygena? Are they one of your competitors?
Yeah, they are indeed. Here's what I say. I mean, this is a webinar to just provide some good information. I don't want to make it a commercial. We think our system is really good. I would hope that you would give it some consideration. Our approach has always been, to try and elevate, what the system can do, and it's really been a focus about that data gathering. I think that's where we really make a difference. But I'm not going to make it a commercial. I would say, thank you, please. If you have some questions, contact a sales rep, and we'd love to show you what our system does. We think it's great. Obviously, I think it's great. But I don't want to, again, make this into a commercial.
Okay. Saritha, can we do ATP swabbing CIP final rinse water for testing?
Yeah, it's a good application. A lot of people do this. Again, I think the important thing there is you establish your baselines for what typical is. And as long as you're thinking in terms of monitoring for changes, then it's a good application.
Okay, Ivan, we have used ATP for hands and never reach an acceptable level even after several hand wash and disinfection. What are we doing wrong?
All right, so Ivan, what I'll tell you is that I am not a proponent of doing this. Your hands will always have ATP. I mean, your cells, you're alive, you're composed of cells. So you test your hands, you're going to find something, and really it's a function of what's on your hands that may or may not affect the reading. So this is an application I've been very skeptical about. I don't believe it's a good one. I think there are better ways to judge hand washing than by using an ATP system.
Okay. Hey, we're getting our money's worth today out of you, Jim. Sabia, what does a marginal result entail? Should we lean towards cleaning or releasing, or is it just good for detecting patterns and trends? So
the marginal result is an area really that's there to give us a little bit of a buffer. In reality, the difference between a score of 149, let's say, and 152 is so small that it would be very difficult to have a very hard and fast line at that point. What people use the marginal range for is the assumption with the marginal range is that it's still okay, that it basically suggests the variability that's inherent in every time we take some samples. that there's going to be some variability, and then this is an acceptable variance. But the fail threshold should be pretty hard and fast. In other words, at that point, we believe something has failed. Our process has failed. So a lot of people look at the margin result just to see where maybe things are creeping up. And if they see that, then that implies maybe a need to take a closer look. But there are also people who don't use the marginal range anymore. They basically just have a pass fail, and that's fine. You can do whatever you want to do with pass, marginal, and fail, and interpret whatever way you think is right, as long as it's based on logic and it's something that you're comfortable with.
Okay. Sarah, what about just using protein swabs for all sanitation verification, including verification?
Yeah, I would tell you the protein swabs are a good indication of general sanitation. Clearly, we're measuring something different. We're measuring proteins versus ATP, but that's fine. What you do get, though, is a little bit less, I don't want to say precision, but maybe that is the right term, because it's generally either, dirty or clean, or with a very little difference. A lot of people, when they're first getting started with sanitation verification, look at protein swabs as that first step. I think as you move your program to a more sophisticated level, you want to see numbers. You would want to see changes. You'd want to be able to gauge improvements, things like that. Much easier to do with an ATP system. But I won't tell you that protein swabs are bad. They're definitely good. They are of some value. Again, it's just something that most people see as sort of a first step. And generally, there's not a real big cost difference. So we typically recommend ATP systems. We do have a protein swab, by the way. And so, like I say, I wouldn't talk anybody out of that. I would just want to talk with them about, all right, what do you want to get back from your monitoring program?
Just a question there from Nicole. Can the ATP test be affected by the body temperature of hands of the person conducting the test resulting in false results?
Well, it could. You wouldn't expect this. If, for instance, you're walking into a refrigerated setting and you're holding the swab or you're putting it in your pocket, whatever, and then you take it out, take a sample, put it back in your pocket, again, that's okay, because as long as it's consistent, we're okay. But again, where there's a variation in temperature, that's when you gotta be a little more careful.
Well, Kathleen, just to bring you in,
Sure.
what do GFSI standards like SQF sort of demand on this area?
The same thing as I was speaking about before, as far as having systems in place that is around the cleaning and sanitizing, that you've validated and you verified your cleaning practices. It doesn't specify, again, the test methodology, but that you have you've done a risk assessment around your product lines, and that you have the adequate testing procedures in place, and they're verified. So the auditors will come in and look for the test methodologies, and that you have the records to support that, and that you've done the testing to support the test methodologies. A lot of times you see that within the facilities, and it doesn't matter if the microbiologist is on staff, but that you have gone through the adequate steps to verify that what you're doing is adequate, and that you're doing something with the data. So a lot of times facilities might do a lot of testing, but they're not really reacting to this information. So we find in the auditing world that that's equally as important, that you're reacting to these test results. And now with FSMA too, and the preventative controls that you know to what's coming in with your suppliers. So this arena of testing and methodology is so important, and the understanding that the management has around what they're doing is is equally important.
Yeah. And is it relevant? Well, obviously, it's more relevant to high-risk foods. Is it relevant throughout the whole food chain? Food packaging. We often get questions on the forum from food packaging companies. Wondering, do they need to conduct such tests and things? What's your thoughts on that?
Yes, they need to understand what their risks are. So it's a yes and no answer, but if they haven't gone through a formal risk assessment, then it's like flying a plane blind without any radar. So you do need to understand if there are risks. There could be risks of things coming in with your or microbial contaminations coming in on your packaging from suppliers. So understanding what you're receiving, and two, around the control measures around what a person can bring in with themselves. So they might be, introducing some sort of contamination to your packaging. So it's risk assessment and having those proper processes, procedures in place to minimize it, even in a packaging facility.
Okay. Just picking up on before we said that ATP is not really relevant for hands because we all carry lots of different bugs, etc. What can you do to validate hand hygiene?
Kathleen, do you have any insight on that? Because I don't know that I know anything more than anybody else about that. I mean, there are ways of, like I was at a conference a couple months ago, and there's a guy who has some sort of a video capture that shows when people are actually washing their hands, and you can wear some kind of an RFID tag or something. But the hand washing issue, I think, is a separate thing from what we're talking about today, which is monitoring your environment with an ATP sanitation verification system. Again, I do not believe that's a good application for that system. I'm sure there are better ways, and I don't know, Kathleen, if you've seen anything more than I have, but
one thing I have seen, I'm not sure exactly how it works. I think it's called glow something. It works with UV light. So you put this liquid on your hands, and you've got to try and wash it off. And then you put your hand under the UV light, and then it shows you how actually difficult it is to wash everything off properly. So that's more of an education tool than
I think it's called Glow Germ. Right?
Glow Germ, that's the one.
I've seen that too, and I think what that does, as you say, Simon, is really it's an education tool as opposed to a monitoring tool. It gets the point across. It's effective for what it does. In fact, somebody just said it's Glow Germ.
Yeah. Okay. Right, I think, can you see any more questions near the top there after that one from Aliu? I don't. We probably missed some that are way down, but, I can't scroll to Australia. What we can do, we can pick through them, and if there's any pertinent questions, we can follow up with those later. So all there is to say is really to Kathleen and yourself, Jim, thanks for joining us today and sharing us your time and knowledge. It's been great. We've a huge amount of. I actually had to, believe it or not, there was a limit of 500 live. I didn't realize because we've never been up to that before. So I had to purchase an extension while we were going to allow more people to come in. But at least we know now, and that won't happen again. But the main thing is we'll send the recording to everybody. So thanks for joining us and for your time. Fantastic. Thank you.
Thank you.
Thank you. It was very interesting.
Right. Great. Ladies and gents, that was Kathleen Wyborn from DNVGL and Jim Topper from Neogen. All there is to do now is to issue your certificate of attendance, which you should see in the sidebar. You can download that now. I will send an email later on with the packaged up the recording, the slide deck, the certificate. We'll put the link into the file that Jim showed before. That basically the presentation was a précis of a much more detailed, let's say, white paper. which will send the link. So if you didn't get that, apologies if you didn't get in, or if you had a few technical problems. I think there was a little bit of a problem with sound. But anyway, we made it through. Hope you got something out of it. Enjoy the rest of your day. Happy Friday. Enjoy your weekend. And we'll see you on the next one. Cheers. Bye.